So hello and assalamu alaikum. My name is Manan, and today we are going to discuss about the remaining formulas of the projectile motion, which was remained in the last video. Previously, we discussed about the horizontal, vertical, their basics, total time to reach max height. Time to reach max height means the total time to flight, max height, range, and max range. We had all these formulas, but we derived only three. Now we have three formulas more. So first of all, that we have is the max height. As we know that max height covers the vertical and the horizontal both, but mainly we focus on the vertical because we are talking about the max height. All right, so for that we can apply the formula which we had, which we previously derived, which was is equal to y is equal to vit minus half gt square. All right, we had this formula. Now see something that we have y, which means max height, will denote by this, that is equal to vi. All right, so we know that vi is equal to v sine theta because we are talking about the vertical component, and v is equal to v sine theta. You can write here vi or vy, whatever you want to write. It is actually vy. All right, it's vy. All right, vy is equal to v sine theta, so we'll just put here v sine theta. And we know the formula for the time that we had in the previous video, which was is equal to v sine theta upon g. Here's the formula. So v sine theta upon g minus half as it is. Then we have the value of g. We'll just put here g as it is. And again the formula for time, v sine theta upon g. So we have applied the we'll apply the square as well. V square sine square theta upon g square. Then it will become g square. It will cut by this, and here will be remain g. All right. H max is equal to v square sine square theta upon g. We multiplied this to this. Then half as it is. Then we have v sine theta upon g. All right. Now please focus on this, that for example this value will remain the same. This value remains the same, and this value multiplied by this means v square sine square theta upon g minus v square v sine theta upon g, means this is a square one value and this is a half of it. So when we minus this value from this, so will remain by 1 upon 2 v square sine square theta upon g. You got it? Or you can write by this like 1 multiplied by v square sine square theta upon g and divided by 2g, like this, v square sine square theta upon 2g. So we have got the formula for maximum height. So now we have got another formula which is of range. It's not maximum range, it's only range. For the range, we know that we cover the range in the x component, which is called horizontal component. So for that we can use the formula x is equal to v naught x upon multi into total time. All right, it is total time. So for x we can put r is equal to range. Vx means v cos theta, because we are talking about the horizontal component, which is equal to vx is equal to v cos theta, which we have derived in the previous video. Multiply by the, we have the formula for the total time here. This is a formula for the total time. So we'll just put here v 2v sine theta upon g. So we'll just multiply both of these. 2v square, we have to rearrange this like this, v square 2 sine theta cos theta, r is equal to v square sine 2 theta upon g. Now you will ask that why did we put sine 2 theta? So we know that 2 sine theta cos theta is equal to sine 2 theta by the trigonometric function. So we have derived the formula for the range as well. Now the thing that I want to talk about the maximum range is that remember these conditions, like where will be the maximum height of the projectile motion. So remember this 45 degrees as 45 degrees only, alright? If I ask you that what are the 2 points where the height can be different but the range will be the same, means for example you have the plane right here and you thrown a ball with the angle of 30 degrees and the angle of 60 degrees. So both will be the same, 30 and 60. Their ranges will be the same but the height will be the different. It doesn't matter, but we can consider the range. So if you want to find that how can be two components, like two numbers can be the same range, so you just have to do 45 45, do 1 plus and 1 minus, same value. Like for example, if I plus 10 and minus 10, here will be the answer 55, here will be the answer 35. At the both numbers, the at the both angles, the range will be the same but the height will be the different. So this was the video, this was the for today. In the next video we'll talk about another topic which is of angular displacement, and we'll just discuss that in detail. So see you in the next video, and for now, bye bye.